Okay, high clicker quiz is up. Anyone have a great weekend they want to tell us about? Someone up here said nobody ever had a great weekend.
It's true.
Come on, when you have calculus to look forward on Monday, how can you say that? Oh, that's why no one ever had a great weekend when they were in a calculus class, because you're not in calculus class on the weekend. It's only during the week, right? You guys get registered for your classes, all right? So when I was an undergrad, I was on the track team here at BYU, but they didn't tell me early on that scholarship athletes could register before everybody else. So they have scholarship athletes register. They have the athletes register early, so they don't have to. So they can always make their practice times, right? So they don't have to battle. But I wish they would have told me earlier that they could register early. And got around the problem of trying to register all the time. Trying to fit the classes. And scholarship athletes are spoiled. We have a few in here, probably. So you were raising your hand. Okay. I know who's on the soccer team here? Yeah. All right. How did you guys do up in Idaho? You won. Nice job. When's your next competition? Yeah. So you can focus on calculus until you got the test coming. All right. Good luck. Okay. Who'd like to start us off with a prayer? Anyone? Thanks, Austin. All right. So soccer is a club sport, right? So you guys don't get scholarships. Do you guys get to register early? And you don't get so you put in all the time, you don't get any of the benefits. So free clothes. You probably get free clothes. All right. Okay. So take some time, look at this. So a fellow student says to you that a series converges if the sequence of terms of the series goes to 0 and diverges if the sequence of terms of the series do not go to 0. So by the sequence of terms of the series, like here, if we look at what happens as n gets large, we can think about what each of those terms goes, where those terms are going. So the sequence versus the sum, which is the series. So your friend says, hey, if I'm just focusing on this and look at what happens as n goes big, if that goes to 0, it converges. If it doesn't go to 0, it diverges. And the question for you is, which of the following series could you use to prove the student wrong? And once you've answered that, then see, some of these you know actually how to find the sum for. Can you actually find the sum for some of those series? Okay. While you're working on that problem, a few announcements. We have an exam this week. So the 30th, 31st, and the 1st. The 1st is a late day, so try not to take it on it. So, I mean, maybe for some of you it's appropriate that the 31st on Halloween you're in taking a calculus exam because it's scary. But I'm sure not many of you. For most of you, November 1st would be the most appropriate day because it's a very it's All Saints Day. It's a very holy day, and calculations. So, yes. So don't take it on Halloween. Save the money. So don't take it on Even though calculus is safe, don't take it on all safe days. We have a couple review sessions. The Math Lab offers some, but also the TAs have emailed out when they have some review sessions, and there's also some extra office hours this week to help you prepare. And please review your first exam, particularly the integration techniques, because all those integration techniques from the first exam are fair game on problems on the second exam. So you're going to be doing a lot of integration. Make sure you know those well. Okay. Any questions? Yes. They are on Learning Suite. They're uploaded to Learning Suite. If you click on your score of the exam, and over to the right, there's a feedback button or an option. You click on feedback, you can download your exam, an electronic copy. Thanks for asking that. Okay, other questions? Okay, take one more minute on this. Oh, I forgot one more thing. I emailed out a survey about how the class is going so far. Only about 40 of you have responded. I would love to hear back from a lot more of you. So please, I'd love to hear back from every one of you so I can get your feedback. This is the first time I've tried this flipped classroom in a large lecture style. So I'm really interested to get feedback, to hear about what you guys how you guys are experiencing this. So please get on and let me know. Okay, take 30 more seconds. Okay, so your answers are chimed in. Okay, what about this first option? What about A? Does the sequence of terms go to 0? Do the terms that you're adding up, do these go to 0? I heard some yeses and some nos. So if we just focus on the sequence, 2n divided by 3 to the n, what does that sequence look like? You get 2/3. What's the next term? 4/9. What's the next term? Oops. What is the limit of that sequence? 0. So these terms do go to 0. The series is adding up all of those. 2/3 plus 4/9 plus 8/27 plus 16/81, etc. This sum, what does that go to? That's a different story. We'll talk about that in a second. But the sequence of terms, each of these, if we just look at each of the terms, where are we going to? 0. Okay, so these terms are going to 0. Okay, does this converge or diverge? Does the series converge or diverge? The terms are going to 0, so what do we know? Nothing. Okay, the whole point of this is what your misguided friend thinks of this problem. If the terms go to 0, then it converges. The terms go to 0 here. Is that enough? No. So, but this does have a form that we know. What sort of series is this? It's a geometric series. What's our common ratio? 2/3. To go from one term to the next, you multiply by 2/3. So our common ratio is 2/3. How do we find the sum of a geometric series? So our first term divided by 1 minus r. Okay? So we went over last time. So we take our first term, divided by 1 minus r. So in this case, what do we get? What's the sum? 2. Does that larger pen help in the back? I tried to increase the width of my writing. Does that help back there? Okay. That was one of the comments on that you guys gave. Okay. So, is A the right answer here? Is A the series you should pull out to show to your friend and say, hey, you're wrong, look at this. Yeah, it's not enough. You need to find a counterexample that goes to 0. The terms have to go to 0, but it has to diverge. Here the terms go to 0, but it converges. You pull this out and say, but look at this. And they will say, yeah, that proves my point. Right? It goes to 0 and it converges. That's what I've been saying. So you don't want to pull that one out of your head. Okay? How about B? How about that one? Michaela said it's basically the same as A, but the constants are different. There is something that is different with this one, though. This one diverges. So it is geometric, but why does it diverge? The absolute value of r is greater than 1. So we could rewrite this as we could write it this way, and then our r is a minus 3 over e, but e is smaller than 3. Right? It's 2.7-ish. So you need more than 1 e to get up to 3. So your ratio is larger than 1. So it's going to diverge. So do you want to pull that one out to answer your friend's question? No, because that doesn't help. She or he will say, yeah, that's exactly right. It doesn't go to 0, and it diverges. Okay, how about C? Where do the terms go for C? The terms go to 0. So you're like, hey, if it's part of what we want, the terms go to 0. Does it converge or diverge? This one, excuse me, you guys do not have a test to handle this one yet. You will on Wednesday. But I actually told you what this sum was on Friday. This was a crazy pi squared over 6. Okay? So this is going to be the one, of all the ones I threw up on Friday, this is going to be the one that you guys, that we won't be able to figure out with the tools you learn in this class. But there's a really nice video on it, YouTube video. It's much more entertaining than me. I'll have you guys watch it if you want. So that's pi squared over 6. Does this help you with this problem? Does this help you with your friend? No, because the terms go to 0 and it converges. Your friend says, yeah. That's another piece of evidence for my argument. Okay, how about D? He's written a little bit differently. We talked about series that are like D. What are those called? Telescoping. Okay. Okay. Do the terms here go to 0? I heard a few hesitant yeses. We can't just look at each of these individually. We need to think about these together as a pair to think about our terms. So at n equals 1, we get 1 over 1 plus 1 over 1 minus 1 over 1 plus 2. So this is our first term. Okay. Then plus, when I plug in 2, I get a half minus
a fourth. So this is our second term. Okay, are those going to 0? The first 1 minus a third, this is 2/3. A half minus a fourth is a half. A third minus a fifth ends up with what? 2/15? 3/15? So this will be 5/15 minus 3/15. So 2/15.
Looks like they're going to 0. Okay. Does this diverge or converge? It converges.
And how do we know it converges?
I mean, I never know if I say, does this converge or diverge? I mean, you guys have a 50% chance of getting it right, so I don't know if you're saying it because we understand or if you're saying it because you're just taking a guess. Yes? So you said it's monotonically decreasing, so you're talking about
each of these, it's going down, right? Decrease, 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 and
you said you don't think you're going to ever get negative, right?
This is always going to be less than this one, and so you're always going to actually be positive.
And so you're saying it's going to converge, right? Is that what you're saying? Okay. So, so you have a bound, right? You were talking about like it's bounded by 0. Is that what you were referring to when you went like this? Okay. So we have a monotonically bounded sequence. So we know that the sequence of terms has to converge. So the sequence of terms, the sequence is always going down. And the sequence of terms, the terms are going to get closer to 0, can't get below 0. So the sequence has to converge. There is a difference, though, between the sequence converging and the series converging. So the sequence of terms will converge,
but our series is actually an increasing series. Our series, we went from 2/3 to 2/3 plus a half to, oops, better not write. Here, so everyone do this right now.
I want you to write out the first 4 partial sums of that series. Okay? We have the first 4 partial sums. Okay?
And then you can compare with a neighbor.
Ask your neighbor if you don't remember what a partial sum is. Or we've got me and Tia are walking around. So. So I started to work it out up here. Did the first two. The first partial sum is just the first term. So 2/3. The second partial sum will be the sum of the first two terms. And the third partial sum will be the sum of the first three terms.
The notation we use, often S1, S2, S3, S standing for sum, or partial sum.
Okay. There's a couple different ways to go from it with S3.
So once we start getting S3, since it is a telescoping sum, we get some things to cancel out. I can cancel out the 1/3, the positive 1/3 and the negative 1/3, and then I have 4 things to add up. I can continue that here. So I still end up with 4 things I need to add up. Or I can I've already got the first 4 added up. So I can just take 11 halves and add to it the 1/3 minus 1/5. So whichever way is easiest for you. So that would be, what did we decide before? 2/15? Is that what we had? What did you guys get for this? (21/20), and then here? Thanks. All right. Okay.
So back to the point that was raised, the sequence of terms is going to 0.
The terms that we're adding up are going to 0. They are getting smaller every time. This much right here, this much right here, 2/3, 1/4, 2/15, etc. These are getting closer and closer to 0.
But our sum that we're adding up is actually getting larger and larger and larger.
Right? We went from 2/3 to 11/12 to 21/20 to 17/15. So 2/3 to a little bit below 1 here, to a little bit more than 1 here, a little bit more than that.
So we're actually getting larger. So the question is, will we keep getting larger here and add up to infinity? Or will we level out at some point? What do we think? How can we use the things we talked about last time to make sense of it? How about you talk to your neighbor right now? Okay? Wake them up. Okay?
Necessarily level 1. This is a telescoping series. How can we go out with a telescoping series? We can figure out what the sum is. All right. Okay. So in this sense, I talked to said the amount you're increasing by is getting smaller each time. But that's still not enough to know for sure whether it's going to converge or diverge. Okay? So, but it is getting smaller each time. It is increasing. But, so how can we know if it's going to converge or diverge in this case? What? The nth term test related to like the telescoping series? Okay. So since this is a telescoping series, we can start writing out terms and look and see what happens as those terms cancel out and the last terms that we have left. So we could continue on here. Notice we've got this term, and every time we add on another one, these terms that we have remaining, what's going to happen to those? Well, we're going to add on, if we add on one more term, we're going to add on a 1/5, and we're going to subtract the 1/7, right? The 1/5 will cancel, but now I have a minus 1/6 and a minus 1/7. And if I added on another term, I'd have a minus 1/7 and a minus 1/8. And if I added on another term, I'd have a minus 1/8 and a minus 1/9. If I add another term, I'd have a minus 1/9 and a minus 1/10. What happens as I go further out and keep adding more and more terms to those last two terms that I have to add? They're getting really small. They're going to 0. So I have these first two terms up here, that 1 and that 1/2, and so I have that 3/2 here, and then I'm always subtracting something that's going to 0. So in the limit, I'm just going to end up with 3/2. So that I have to be sure to check that nth term, those end terms here, to see where they're going. I'm going to end up with things like a minus 1/6 and a minus 1/7. But since the limit as n goes to infinity of these things, both terms go to 0, I'm going to be okay. So what does that tell me about this limit of the sequence of partial sums here? We saw that the sum, if we think about it as a telescoping series, the sum is going to be 3/2 because we have this 1 here, we have this 1, and we have this 1/2, and the remainder terms over here, like my minus 1/5 and my minus 1/6, those are just going to get smaller and smaller as we go to infinity. So the sum's going to be 3/2. What does that tell me about the sequence of partial sums? What's the connection between that and the sequence of partial sums? The sequence of partial sums, what's the limit going to be of all of these terms as they go on to infinity? It's got to be 3/2. The numbers that I get as I keep adding further and further into this series that sum's going to get closer and closer to 3/2. So the sequence of partial sums is going to get closer and closer to 3/2. And the way we define the limit of the series, the way we define that series, whether the series converges, is we look at the sequence of partial sums. If the sequence of partial sums converges, then that's what we say the sum of the series is. So, okay. All right, we haven't finished this problem yet. So, there's only one left. So it's got to be that one. All right. E. This series has a special name. What's it called? A harmonic series. Okay, the harmonic series, does it converge or diverge? It diverges. And I didn't give you guys a proof last time that it diverged, right? I said I would do that today. So, let's get a new color. This is the one they mention in the book. So someone more clever than me realized that you can start taking chunks out of this series and add up things to get at least 1/2. And you can do that as many times as you want. So 1, it's at least 1/2. 1/2 is equal to 1/2. But then if I go out 2 more terms, I have this 1/4, and the term before it, 1/3, it is at least as big as 1/4. So I have at least 2 1/4, and 2 1/4 is at least 1/2. So that is greater than 1/2. And now I'm going to go out 4 terms. So here I had 1 term, here I had 2 terms, here I had, take 4 terms, and the smallest term here is 1/8. And I have 4 terms that are at least 1/8, so the sum of those has to be at least 1/2. If I take 8 terms, and the smallest one will be 1/16, and so 8 1/16, 8 things that are at least 1/16 adds up to at least 1/2. And then I can take 16 terms, then I can take 32 terms, then I can take 64, and I can keep on going. And since it's an infinite sequence, since it's an infinite series, will I ever run out of numbers? No. So I can keep going out and keep adding 1/2 plus something that's at least 1/2 plus something that's at least 1/2 and something that's at least 1/2. And keep going. So I'll never reach a limit. I can get as large as I want here. This series, this harmonic series. Okay. You said the terms are getting close to 0. You're adding up. Oh, are you thinking about like the integral of 1 over x? So he's thinking, for those of you that can't hear, he was thinking about something that he remembered from chapter 7, where the integral of 1 over x from x equals 1 to x equals, well, I'll just do infinity, dx, we did this problem, and we found that it diverged, right? Okay, and this seems similar. Both a sum and an integral are adding up quantities, right? And this infinite series and the integral, they're actually adding up infinitely many things. So this is actually very good thinking, and we'll be able to make that more rigorous in 11.3, where we have what's called the integral test. And if you have a sum of a function of n, and you have an integral where these are the same function, then if the integral converges, then this series converges. And if the integral diverges, that series diverges. So it's actually a good thing. Okay, someone had their hand up. Yes? No, it's a proof that works really well for that particular series, but for the rest of for like the next 4 or 5 sections, we're going to be giving you better tools to decide whether things converge or not, like the integral test. Okay. Good question. All right, so the harmonic series is the one you should pull out to show your friend when they say, hey, if the sequence of terms goes to 0, if the series converges. If the sequence of terms don't go to 0, it diverges. So pull out the harmonic series and say, that is not the case. And unfortunately, in spite of going over this so much, some of you are still going to think that on the exam coming up. So don't. I know. Okay. Here's a problem. This is from a junior high textbook. Junior high math textbook. This shouldn't take you too long. You can use whatever math you want to solve this problem. Okay, already seen a few people come up with an answer. What have you guys got so far? 217. Get something a little less than 217 to round up. So you're wondering, like, why in the world? 216 and 230. Right? And why in the world? Well, this is a problem that my daughter had in junior high. And she was struggling to find the answer, and this is the process she started to do to find the answer. She said, okay, I need to make up $3,250. Thanks. Okay. Thanks, Christian. I know someone else probably said that before, too. My bad. So, $3,250. How many books do I have to sell to make $3,250? So $3,250, I make $40 per book, so that's 81-ish. I think that's what it is. Books. But now I have to print 81 1/4 books, and that's going to cost me more money. How much more money does it cost? Well, then I have to take that times $25 per book and get some other amount. But now, how many books do I have to sell for that amount? So this is the way my daughter started to solve this problem. I let her do that process start a little bit, but I didn't let her go all the way. I'm not that mean of a parent. So here we have. All right. So here I have this spreadsheet set up. Here's my original number of books. I divided by 40, got my 81.25, but that 81.25, now I have to pay $25 per book of that 81.25, and it's going to cost me another $2,031.25. And so now I have that much more money. I have to figure out how many books I have to sell to make up that much money. So I divide by 40 here, so it's about 50 books. But then to print off another 50 books, it takes this much money, and et cetera, et cetera. So whatever value I take, however much more money I need to make, divide by 40, figure out how many books that is, but then it costs another $25 for every one of those books. And this column here, the total is going to be how many books I need. And what's the sum of all those? I didn't do it all. Right? I could keep on going mathematically, but already I'm down to 1/100th of a book, or 1/1000th. So 216.66. Okay.
take a second, see if you can figure out what kind of series this is. So here's a series
My daughter started to use, and she was taking 81 plus 50 plus 30. Can you figure out what kind of series this is? So take a minute.
It's not one you can get just by looking at those numbers. You want to think about the process that my daughter went through to get those numbers. All right. So, to get a handle on what kind of series this is, you want to pay attention to the process that we're going through.
So I'm just going to start writing down how we calculated each of the books, number of books at each step. So I had $3,250 divided by 40. And then what do I have to do to get that second number of books? It was around 50. So how do I calculate that? I can take the number of books I had before. Right? So I had this 81 right here. Okay, and then how much more money was that going to cost me to print off those 81 books? I have to multiply it by 25. So times 25. But that gives me an amount of money. And then what do I have to do? Divide by 40. And then how about B3? So I take the number of books that I had, and I have to multiply that by 25 to figure out how much more money it was going to cost me for those, and then divide by 40. Okay? What happens each time? Every time I'm multiplying by 25/40ths. And if you guys had this spreadsheet sitting in front of you, I'm sure some of you would have thought about doing this and said, well, I'm going to take this number and divide it by this number. Do that the other way. I'm going to take this number and divide it by this number. And do that a whole bunch. This divided by this one divided by the one above it. This one divided by the one above it. Each one of those, I get the exact same ratio. So here you can see that it's a geometric series. So, and how do we calculate the sum of this geometric series? We have enough to do it. We take our first term, divide by 1 minus, what's our common ratio? 25/40ths, or 5/8. And you get 2/16 and 2/3.
Now, This is overkill for this problem, right? Okay, of course, this is overkill for this problem. But the thinking my daughter did actually works really well for a lot of problems where you can't just do one calculation to get the answer. Iteration is a powerful tool that we use in science and mathematics to creep up on answers we can't get at directly. And sequences and series are the tools we use to creep up on those. There's a whole field called numerical analysis that's about how to program computers to using iterations like this to get us the values that we can't get at directly.
There's actually a nice geometric interpretation of this. I heard some people talking about equations of lines. Here our revenue is 40x. Here our cost is 3250 plus 25x. Our process, what we did was we started with our initial cost, and we went and we figured out how many books that was. That was about 81 books. And then we figured out how much more cost, and then figured out how many books. That was about 50 more books. And then we went up and over and up and over, and we converged to this point, which was 216.666. And if you know much about chaos theory, you can start seeing some connections there. All right, have a great day. You're welcome. We'll see you.